now welcome Dr. Griffith to give evidence today.
Afternoon.
How are you, Dr. Griffith?
Oh, it's always nice to be the second best beard in a room.
For the Hansard record, would you please state your name and the capacity in which you appear before the committee?
Dr. Saul Griffith, Chief Scientist.
Can we have a little bit of silence on the back, please? If you'd like to have a conversation, you can go outside.
Can we have the conversations outside, please, guys? Thank you. Thank you. We'll just do that again, Dr. Griffith, please.
Dr. Saul Griffith, Chief Scientist and co-founder of Rewiring Australia, also founder of Rewiring America.
Thank you. This hearing is a legal proceeding of the Parliament. The giving of false or misleading evidence is a serious matter and may be regarded as contempt of Parliament. The evidence given today will be recorded by Hansard and attracts parliamentary privilege. Before I invite you to make a brief opening statement, then we proceed to discussions. Would you please state if you're a current or former member of a political party or a union or an investor in the renewable or nuclear industries, please?
Member of no political parties in any country I live in. I'm not an investor in renewables or nuclear as classically defined, but I do run a startup incubator in California and we develop renewable energy technologies, but we also have a fusion fuel cycle startup in our basement.
Excellent, thank you. I now invite you to make an opening statement.
So Saul Griffith, I'm, by way of brief background, did metallurgical engineering here in Australia at the University of New South Wales. Worked in the steel industry in Newcastle and aluminium industry in Sydney for my first couple of jobs. From there I went on to MIT to do a PhD. I did that at the intersection of information theory and material science. While I was there, I was lucky enough to have friends in the nuclear engineering department. It's the only university in the world to have an operational nuclear reactor on campus, so you get to go and not quite spin the dials, but at least learn how it works pretty well. Had an extensive career doing projects with the Department of Energy, advanced research projects for new energy technologies, and have had extensive experience, including, probably relevant to this conversation, being on the advisory board of Duke Energy. They run 11 nuclear reactors in 6 plants in the Carolinas. I visited a couple of those plants and spent time in them. Also visited plants in the UAE that were just mentioned. Have authored now 3 books, just finishing a 4th on climate and energy. I'm aware of all of the climate science, but I'm really an energy expert. The book Electrify really outlines the case that our solution for climate change goes largely through electrifying all of our energy systems. So that means not just cleaning up our existing electricity, but roughly tripling the amount of electricity we deliver so that we can electrify transportation, electrify heating, electrify industry. So part of that work, I've studied a lot of countries all over the world, their whole energy systems. Just in fact this week completed a detailed study of the Taiwanese energy system. They have a fairly existential challenge to keep their semiconductor industry going, but they're a tiny island without a lot of room. So they're having an interesting nuclear conversation with Big Brother looking over their shoulder. So, you know, I have on-the-ground experience with nuclear and the conversation at nation-state level in a couple of places. Really as a conversation here in Australia, so a number of years ago, I drew a map of the world, which was population density versus energy required to run that country with an energy surplus roughly equivalent to America, which is one of the highest energy per capita countries in the world. The interesting thing about electrification with renewables is you'd only need to generate 40 to 45% of the energy we do today to be able to run the whole economy. That's the efficiency win of electrification instead of burning fossil fuels. But when you draw the map of all of those countries, one thing stands out. Australia sits in the very bottom lower right-hand corner, which means we have the most land with the lowest power requirements per capita. And you can draw 3 lines on that graph. Countries that need less than 0.1% of their land covered with renewables, just a 50-50 mix of solar and wind. And Australia is pretty much the only country, apart from Kazakhstan, that could use less than 0.1% of its land to power the entire economy with renewables. So we have the easiest run at and the easiest case for renewable electrification of any country in the world. A country like America would need 1 to 1.5% of its land to be covered with renewables, wind and solar, to power itself. That's achievable, but if you would like to imagine what that looks like, it means covering a land area equivalent to the land area covered by roads and highways. So if you've ever been in America, imagine every road you're driving on, there's a road next to it made out of solar cells and wind turbines. That's how much land you need. Then you get to countries like China that would need 10% of their land area covered with renewable energy if they were to live an American lifestyle and need 4,000 watts per person. That's probably difficult to imagine. And then you get to places like Taiwan where they would have to cover the whole island and some of the Chinese strait in between with offshore wind to do it with 100% renewable. That's why in the book Electrify, I said, we can probably expect some of the future to be met with nuclear power, particularly in cold and populous countries. They might need it, or as in Europe's actually taking an efficiency approach, which might get them there. But I think you will see, Finland just brought nuclear online. Pretty hard to get through a Finnish winter without it. But countries like Australia, Mexico, much of South America, we do not need nuclear at all to hit our energy goals, our climate goals. So that's just sort of baseline it in a physical reality. Just to list other concerns, the reality is nuclear is expensive and also difficult to pin an exact price on. If you take unregulated nuclear that the Russians are building inside Russia, it might be penciling at 5 cents a kilowatt hour, but in the US, new builds are going in at 20 cents a kilowatt hour. That's before it even hits the grid. In Australia, we have a remarkable situation where rooftop solar on our rooftops is delivering electricity to Australians about 5 cents a kilowatt hour. Even if nuclear energy was free, it would cost about 13 cents to get to an Australian household, and that's the cost of the transmission lines and the distribution lines and the other pieces of the electricity infrastructure required to get it there. So you can say simply and definitively nuclear is not the lowest cost pathway for Australia to get to zero emissions. We are a water-starved nation. You need 1.8 to 2 litres of water per kilowatt hour of electricity you produce with a nuclear power plant. In many of the southern states of America, you can bring no more thermoelectric power plants online because they've run out of rivers that you can warm up. So what you do is you typically take cold water in from a river or groundwater. It heats up as it cools down the plant, and then you put it back in the stream, but if it goes above a certain temperature, it kills the fish. You might remember the heat wave in France about a decade ago that killed a whole lot of people just when they needed the nuclear power plants to work harder, to run all the air conditioning. The river water got too warm and they weren't able to cool them, so they had to throttle down the plants, and that's why they lost energy. So in a water-constrained country like Australia, nuclear is pretty difficult. Japan's solution to being water-constrained was obviously to cool it with seawater. That led to other problems. We don't have quite the earthquake problems of Japan, but I think there's going to be significant, in Australia with our love of coastlines, significant social license problems with using seawater for cooling. It also increases the cost because you have to do corrosion-proof heat exchangers, etc., etc., etc. Just an anecdote, because I heard it mentioned from the previous people. When I visited the nuclear power plants in the UAE, I asked them about the water temperature of the local bay, which receives the output water, and it was at 52 degrees Celsius and was clinically dead. So no fish, no reefs, no nothing, because the 3 operational nuclear power plants were using seawater, and then they were dumping it into a bay, and the temperature was killing everything. So we should think about that. I remember an experience the first time I saw the control room at Catawba nuclear plant in North Carolina. It was a 45, 50-year-old plant, all run analog. you walk in, you'd say, oh, immediately I could halve the cost of this thing because since we built this plant, we invented digital microelectronics and control systems got cheaper and faster. So you ask them that question, and they say, well, we don't really want to do that because then you have to connect your nuclear power plant to the internet, and that's a problem. But the most telling thing when I asked the plant operator what was one of the more significant cost drivers of his plant, he said was the security detail. Once a year, they have to have a false flag SEAL Team 6 come at random and do a false charge of the plant. And I drive that anecdote because part of the reason they do that is America still has not found a solution for its nuclear waste. So basically, the low level and high level is stored in what amounts to a swimming pool at the back of the plant. And so they have to take a lot of care to monitor all of those. Anecdotally, there's a number of people who don't believe that the accounting is correct and a few of the things have gone missing. But, you know, as well as all of the other regulatory things we would need to do to have a real nuclear industry here, you know, I would question our capacity in the military sense to defend them in that sense. I think it's worth looking at the situation in Ukraine right now. Very, you know, for climate and geography reasons and historical reasons, nuclear heavy grid there, but that is precisely their weakness now that they're at war with Russia, and there's been constant battles and concerns over the nuclear power plants there, and a number of them are now out of operation. So I think people will use security arguments in favour of nuclear, but I think you can use as many security arguments against. Certainly watching the conversation of the Taiwan legislature, they are split evenly between, if we had a nuclear power plant running our computer chip manufacturer, that means China won't invade us, versus if we have it, the other half of the legislature thinks it'll invite them to invade us and we won't want to give in because it's too risky if it's run off nuclear. I think to sum up those in a finishing statement, just to keep my opening statement reasonable, if you model out the energy future possibilities for Australia, a lowest cost energy system very unlikely has any nuclear power in it. My personal opinion is that a lot of the advocates for this nuclear revival in Australia are unwittingly playing to the fossil fuel industry's hand, which is this is an extremely smart delay tactic to keep slowing things down. So that's unfortunate. Just when, you know, Rewiring Australia is going to, in January, put out a new study. If we went as hard as we could at rooftop solar and commercial solar in the next decade, we'd save Australia $1.7 trillion by 2050 and we'd hit our climate targets. You cannot say that of nuclear. It's not going to make the electricity system cheaper.
All right. Thank you, Dr. Griffith. We'll go to Mr. Kennedy first up.
Yeah, hi, Dr. Griffith. Thank you. Look, we've heard a lot of evidence from different experts and academics, you know, folks at Princeton University who worked on Australia's net zero plan and the US net zero plan. Their view was...
Was that Jesse Jenkins?
No, that was Dr. Greig. I think his first name was, I don't know, was it Tim? I don't know, Dr. Greig, Australian guy based in Princeton, who worked on both Australian net zero and US zero. I can try and find his first name, Dr. Greig. But he was one of many. We've heard a bunch of testimony earlier this morning as well. We heard from the former South Australian chief scientist. Anyway, a whole host of folks saying they think it's going to be very difficult for us to hit our renewable targets, 82% by 2030, net zero by 2050. They said as we electrify, they even think that'll be even harder. And as we look to scope 2 and 3 emissions, it's going to be even harder still. And their view was we should be looking at nuclear. I think one of the witnesses said something, we had no chance in meeting us. And we need to throw everything at this problem. You seem to have a different view to all those people. Why? What are they missing? Chris Greig. It was Chris Greig from Princeton.
he's a
But yeah,
colleague.
what are they? So Chris Gregg, the chief scientist from in South Australia, former chief scientist, the whole host. What are they? They're telling us that even, there's been reports from Chris Minns and Matt Keane in the press saying, look, we're going to struggle. Why do you not share that view?
Oh, we will struggle, but it's not for technical reasons. We've known roughly what to do to meet our climate requirements for 30 years in terms of electrification and doing it with renewables or nuclear. And lots of academics have done those studies. Mark Jacobson from Stanford most famously did the How to Power the Whole World with water, wind and solar. That's 20-year-old work that still feels fresh and relevant. Whether you power this electrification with nuclear power or with renewables, there is no way that the free market can hit any climate target better than 2 degrees. And so part of the reason you're getting these answers from people, we need to throw everything at it, is nothing short of a wartime economy where the government takes control of economic levers to compel industry to build all of the solutions faster than industry would otherwise, will hit the target. I say that confidently because if you let every existing machine on the planet that burn fossil fuels to the end of its life, that takes us to 1.9 or 2 degrees. So that means you've got to shut things down early to hit any reasonable climate target, and you've got to replace it with something. Now, in World War II, America did that famously with something called the Arsenal of Democracy, where they offered 7% profit for any manufacturing firm that could manufacture any of the 7 critical war materials required to win World War II, which were boats, guns, jeeps, airplanes, and radio equipment. I think that was at least 5 out of 7. To be honest, and this was one whole chapter of the book Electrify that I wrote in 2019, was the only way America and the world can hit its target is if America takes the lead on doing a manufacturing effort like that. Now, it turns out that China has done a manufacturing effort that looks like that they began with the China Made in China 2025 policy that they started in 2014. That's why they are producing 90% of the world's solar cells, 90% of the batteries, and 30 or 40% of the world's cars. So they took it seriously, but that's because they didn't have a domestic fossil fuel industry. So buying from Iran or Russia or America, didn't matter where they were buying their fossil fuels from, wasn't a great option, and they needed to clear their skies for public health reasons. So China is the country that's putting in the level of effort that is required, including building nuclear power plants. But as I mentioned before, they don't really have an option not to. But, I think to say we're going too slow and it's too hard is, well, obviously that is true. Are you actually ready to be serious? And I think a number of experts could give you 3 or 4 different pathways to success if you were serious and you tried to do science-based policy to hit the target.
And look, this is probably, I don't know whether this was deliberate or a slip of the tongue. When I hear what you say about we need this wartime footing, we need to move extremely hard and have government run through barriers like we haven't before. I hear you on all that. You said one thing on whether that's nuclear or renewables. Given that sort of wartime footing, post-World War II manufacturing, why wouldn't it be nuclear and renewables and not slow down? Why wouldn't we look at, no, let's go hell for leather. Let's take that wartime footing that you just described and say, let's push both of these things as hard as we can. Isn't the downside just oversupply and cheaper energy cost? Why would we not do that and do it as an and rather than an or?
Not to put my words in your mouth, but it's unscientific to say we want to solve climate change and we're not allowed to use one option. So I think Australia should be in the market of trying to make the new nuclear technology that might be the solution. But right now, we're trying to sell to the Australian public a solution that isn't real yet. So if we're honest and we say that this is that a next generation nuclear power is a research project and Australia should be in the game because we have smart young people, I would agree with that. Should Australia be in the game of trying to be at the forefront of fusion energy? Absolutely. I have 3 friends who are running nuclear fusion companies. They believe that they will have reactors running in the mid-2030s. I don't see anyone talking about why Australia doesn't have a serious fusion project.
Yes. So you're advocating for, look, let's push all technology.
I'm advocating you should push all technology, but you should not sell things that are not working technologies yet to the Australian public as working, that we know from where we are will be more expensive than other solutions.
Yes, but so taking that rationale, like, is it worth us doing the ISP again with nuclear as an option? Because I know we've got, chunks of hydrogen in the 2040s in the ISP, and from what experts have told us, that looks increasingly uneconomic. Should we be looking at, multiple scenarios rather than just a step change scenario with a host of different technologies? Is that, couldn't the same criticism be leveled at that, or am I thinking about that?
No, you're thinking about that great. If you want to criticise the ISP, you should ask why the hell they even thought hydrogen was a good idea in the first place. I mean, high school students could see the inefficiency of hydrogen would kill the economics 10 years ago. So it was the gas industry's hands on the people who write the ISPs who gave you those results. The ISP has a further problem that it doesn't model the lowest delivered cost of energy. The ISP only models the cost of energy as it exits the generator. That's because the ISPs are driven by EMO and they really only operate the market up to generation, the wholesale market. So that's why the ISPs took forever to figure out that this rooftop solar was cheap and these electric vehicles running off rooftop solar are going to be even cheaper, because they were not thinking of the delivered price of electricity. This unfortunately doesn't play well for the nuclear conversation, because we now know that even if nuclear is free, rooftop solar will be half the price. Delivered to customers across Australia.
So, and on rooftop solar and consumer energy resources, batteries, EVs, whatnot, how do we think about that with, there's a capital cost that consumers are going to have to bear. Not every consumer can bear that, right? Particularly right now in our land, politics land, cost of living is super hard. People don't have tons of capital they're sitting on. And I know it's not costed in the ISV because they're saying, that's not there. Other people,
scope, right? It should be put in scope. Hopefully we agree on that.
Yes. Yeah, so you think we should cost that, and do you have a view on the size of that? So that, just maybe you can clarify and expand on that.
I have a strong opinion, and maybe you'll enjoy hearing it. The Australians will spend $2 trillion between now and 2040 buying vehicles, buying the kitchen hob, buying batteries, buying water heaters, buying space heaters. If they spent $2.1 trillion, they could buy all electric versions of those things, because the costs are basically at parity right now, and if they aren't, they will be in the next couple of years. So for that extra $100 billion, they're going to lock in $1.7 trillion in savings. It's the biggest money-saving, nation-building effort that Australia could run. I've been shouting this from the rooftops for a couple of years now. It is such a good deal that the Australian government absolutely should be in the deal of using its super funds and other financial mechanisms to help every single Australian household afford it. The problem isn't if it's going to save Australian households money. It'll save the average household $4,000. Who does that $4,000 count the most to? It's not the people who can afford a Tesla in Toorak. It's the single mum in Western Sydney who's got a hell of a commute who would save $2,000 a year in an electric car. So what you need to figure out is, how are you going to finance Australia to get into this fundamentally lower cost, renewably powered electric energy system? That's the debate we should be having, not about mythical technologies that might be on the grid in 2040.
And just to be clear,
Mr. Kennedy, final question.
Yeah, okay, final question. Yeah, just to be clear, so I understood your evidence on that last one. You're saying that the costing of that, which would enable that mum in Western Sydney to do that, is not in the ISP, and then therefore we should cost it because of those benefits. And if so, roughly how much is it? Just that's sort of it's a question there. I'm just confirming I'm following you.
It's a great question. I think we've done the best modelling, but I wouldn't want to say it's sufficient, because we're a non-profit that's understaffed. But Australians will spend $2 trillion buying cars and appliances over that period, and if they spent $2.1 trillion, they would have all electric clean ones that would run much cheaper. The easiest way to understand it is it's $2 a litre to put petrol in your car. It's about 20 cents a litre equivalent if you're putting rooftop solar into an electric vehicle. So you're saving 9 cents every kilometre.
So that's a $2.1 trillion capital cost that you would say would have ongoing operating savings.
Think about it as the differential, right? We've got to spend a little bit more to buy slightly nicer things that save us money over the long run.
Thank you, Mr. Kennedy. Mr. Burnell.
Thank you, Chair, and thank you, Sol, for providing evidence today. I just wanted to go to some comments that Mr. O'Brien's made on a number of occasions, because I note in your opening statement you talked about water being an issue here in Australia under the consideration of potential use for cooling of nuclear reactors. And the positions always, well, we can go to dry cooling reactors. I'm just interested to get your thoughts on the efficiency of dry cooling reactors. Do they have a place in Australia? Are there areas where they can work or where they won't work? And if we've got water restrictions, what is the alternate then?
So we were involved with a Department of Energy program that started about 8 years ago. I can't remember the acronym. They love terrible acronyms at the DOE. But it was, how do we do dry cooling, not just for nuclear, but all thermoelectric power plants. We believed, as did a whole bunch of people, that there are workable solutions. They suffer the problem of scale. So one of the reasons rooftop solars took off, batteries and electric vehicles take off, is you can get into the market and be selling them for fairly small investments and you can start making money. The very first dry cooling system you install on the first gigawatt thermoelectric power plant is going to be a couple of $1 billion worth of experiment. And so it's very hard to bring that type of technology to market. So ultimately all of the groups that were on that program had things that you would describe as interesting, but there was no pathway to market because people aren't building a lot of new thermoelectric reactors, and the new wind and solar technology doesn't need any cooling. So it is technically possible. Basically, it means you have giant heat exchangers, you have a giant pond, you run it through the heat exchangers, you store the water in the pond, you might use radiating it into the night sky, which would work in the centre of Australia pretty well. So the temperature of the sky is 4 degrees Kelvin, so you can radiate pretty effectively, but you have to hold the water until night time. So there's a few of those tricks that you could play, and that would probably be necessary if you were doing anything but a de minimis amount of energy with nuclear power in Australia, which is what I would describe the current plan is, a de minimis amount compared to what we need.
Right. Do you believe we need baseload power into the future?
Baseload power was invented to describe the problem of coal.
Right.
Which is you can't turn them off. So then we changed shifts so that we couldn't turn them off overnight. Let's run a night shift. We designed modern society to work around the inertia of those systems. So what we really need as baseload power is a very, very small fraction of what is commonly known in the disinformation sphere. It's probably 5 or 10% of what you think. It's not 50.
Right. I'll just go to social licence. The coalition is saying 2.5 years for consultation with communities. Do you think that is the appropriate amount of time to get communities on board? And I'm mindful that also, and I'm keen to get your thoughts on this, but should communities have the right to veto? If the 7 communities that have been slated for these reactor sites, if one of them come out and say, you know what, all the facts are on the table and we don't want to do this, should they have the right to veto and say, no, it's not going to come here?
I want to go as close to not answering the should they get veto question as I can. Mm-hmm. I've just witnessed in my own community, which is Wollongong and North Wollongong, the incredible misinformation campaign that was thrown up against the offshore wind, it's hard to believe that we won't see similar hijinks around a nuclear conversation. I don't believe the public sphere can have a rational conversation. This is a larger question about the information ecosystem we live in. And so I'm unsure you can get social license for any of these projects, which is really, I think, probably the hardest problem about solving climate change. We've sown so much misinformation over 2 or 3 decades that people don't know what to think. And they're not armed, you know, at least in America, they publish all of the Information Energy Administration publishes all the public data on energy use, so at least if you're a concerned citizen, you can go and look at it and figure it out for yourself, but we don't even publish all of our data here. So I think it's pretty hard for citizens to be approached. My intuition, given that my phone is ringing off the hook and my email inbox is full of people who say, come and help us fight for nuclear. I mean, Dick Smith calls me once a week to say, why aren't I for nuclear? And then I've got as many other people saying, we're going to shut this down in our community no matter what happens. I don't think social license, that's why I feel really, this looks more like a delayed tactic to me than a serious effort to do nuclear power as yet. If it was a serious effort, we wouldn't be saying small modular reactor so often, right? When I was at Climate Week in New York this year, I spoke to the head of nuclear power for GE. You know, they're a little company that builds nuclear power plants. Mm-hmm. And he said, he was very proud. He's like, we did a great job this year. We redefined SMR to mean 330 megawatts. So our existing light water reactors are now SMRs. So the reason we're going to get SMRs is because we're going to redefine a 60-year-old technology, right? We don't even understand where this stuff is in the conversation here. So it's a little hard to answer your question.
All right, thank you very much.
Thank you, Mr. Burnell. I just got one question. Can and should nuclear power play a role in replacing our coal-fired power stations as they come offline?
They could. Technically, they could. I believe in Australia's capacity to build it. Do I think that we will do that without creating a lot of social disharmony? No. Do I think it'll lead to a lowest cost energy system? No. Do I think it's the best path to go at speed? No. Do I think we should at least run research projects into next generation nuclear or fusion that might solve these problems? Absolutely. We're a smart country. We should be in the game of trying to make the innovations that change the world. But we shouldn't be rebranding 60-year-old technology and crossing our fingers and hoping it works.
Very good. Thank you. I'll just go on to one more question just while I'm here. I've got a little bit of time. You said mis and disinformation. Is it hard right now to get out any information, considering we have a 5-page document with a front cover on it that's a nuclear policy from the opposition that says they're going to have 7 sites around Australia. They are the only sites they're going to have, but we have no other information. We don't know what reactor they're going to use. We don't know how many reactors on each site. We don't know how much water they're going to use. We don't know how much they're going to cost. We don't know how long they're going to take to build. Do you think it's hard to even get any information out when we don't have that bit to start with?
You know, I can't count 7 rivers on my hand that have a gigawatt worth of water flow in Australia. So 7 seems pretty hard unless you're putting them all on the Murray, and I think that's under stress. So it doesn't look like a serious attempt at energy policy to have this document in this way. I mean, I've been trying to get information about it. There's not enough there to seriously answer many of your questions because there is no detail. If you were to really be having this conversation, you should be talking about the demand side and the supply side. So how much electricity are we actually going to need? There can be a little bit of criticism of the Labor government as well as not doing a good enough job of telling us that, but they've done a better job than the party that's presenting this. But we should know where we're going and we should understand the trade-offs. And I think, you know, if you made reasonable assumptions about what those 7 sites would be, it looks like being 3 or 4% of our current electricity supply and maybe 1% of our future supply. So it doesn't add up to a credible national energy policy. And if their real goal is to do 70% nuclear, which I just heard here a few minutes ago, that's entertaining, then, you know, state it up front. Let's have a conversation about that. You know, science says experience says nuclear works, but you've got to fill in details and you've got to be serious. And then in Australia, you have to compete it against an unbelievably low-cost renewable incumbent. Somebody just installed a battery in Western Australia last week. I think the total cost of storage on that battery is going to be 4 or 5 cents per kilowatt hour. With rooftop solar at 4 cents a kilowatt hour, that's 24/7 hardened electricity at under 10 cents. You can't get the nuclear electricity from the distribution substation to the house for less than 10 cents in Australia.
Would you say it's just a tactic by the opposition to divide Australia?
If I thought they were being tactical.
Thank you for your evidence today, Dr. Griffith. If you've been asked to provide any additional information, including questions on notice, please forward it to the Secretariat by Friday the 10th of January 2025. Please note the responses to questions on notice will be published on the website as submissions to the inquiry. If you will be sent a copy of the transcription of your evidence today to assist you with answering questions, and a copy of, you can request to get corrections to the transcription errors. I'd like to thank everybody who's been here today, the audience. I'd like to thank the witnesses. I'd like to thank our wonderful broadcasting team and Hansard for what they're going to do. I'd like to thank the Secretariats for all the hard work they put in, and thank you to the committee members that were able to show up today. Thank you very much, and I look forward to seeing whoever comes over to WA with us next week. Cheers, thank you.